Hello and welcome to Climate Check from BBC Weather. 2020 is already turning out to be a record-breaking year and we're only halfway through. It was the warmest May globally since records began, and yet again the biggest temperature anomalies, in the darkest shade of red here behind me, were at the poles. Temperatures 10 degrees above average in parts of Antarctica, Alaska and Siberia. In the UK, May saw the highest number of hours of sunshine ever recorded in 1 month. Data is measured using sunshine recorders like these, where the sun burns through the glass onto a special card, although more modern sensors are in use now at some weather stations. And busy sensors they were through spring. Averaged out, there was a whopping 626.2 hours of sunshine across March, April and May, and that's more than you'd get in a typical British summer. So, what was that weather pattern? Meteorologists refer to them as blocking highs. The jet stream that steers areas of low pressure in from the Atlantic, the major source of rain in this part of the world, was buckled considerably further north than you'd see in a typical spring, taking the rain north along with it, allowing high pressure to establish or block for weeks on end. Consequently, northern France and the Benelux area all had a much drier spring than usual too. Sustained rainfall shortage is an even bigger concern elsewhere in Europe, the worst in a century for parts of Poland and Romania. For the Czech Republic, it's having the worst drought in 500 years. The lack of soil moisture is now visible from space and is being monitored by satellites. Compare the average spring soil map with the green shading with this year's in red. Some places are 30% down. The dry spring followed an exceptionally wet February in the UK, the Netherlands and parts of Scandinavia. These side-by-side maps from the Met Office show the dramatic contrast between the very wet February in the UK and the exceptionally dry spring. Scientists are also finding increasing evidence, though, for this seesaw behaviour elsewhere around the globe. In fact, Princeton University is looking at apparent hotspots in Asia, Africa and Oceania and studying the possible links to climate change. Staying extreme, let's look at our planet's biggest storms. The 1st of June marks the official start of the Atlantic hurricane season, and it's the 6th year in a row there have been pre-season storms, but this is the first time we've seen 3. In contrast, after the earliest ever tropical depression, 1E, showing itself in the Pacific Basin in April, overall it's a pretty slow start to the season here, just 2 systems so far. And the US Weather Service, NOAA, has an ongoing investigation as to whether this shift is tied to climate change. What we do know about these powerful storms, hurricanes and cyclones, is they draw their energy from warm ocean waters. 26.5 degrees Celsius to be precise is necessary for their formation. So with warming waters globally, we've seen about a degree or so rise since the beginning of industrialisation. It's more likely for these powerful storms to form. And certainly that ties in with what we've been observing in the northern Indian Ocean in the last few weeks. Supercyclonic storm Amphan in mid-May was one of the strongest ever seen in the Bay of Bengal. Supercyclonic storm Nisarga in the Arabian Sea was the most powerful storm to make landfall into the Indian state of Maharashtra in the month of June since 1891. And the timing of those 2 storms may impact the onset of the Indian monsoon, as they've disturbed both upper and lower level atmospheric patterns. Climate scientists will certainly be staying glued to the observations. Has our exceptional spring set us up for potentially a summer of record-breaking heat in the Northern Hemisphere? And of course, just how will the rest of the 2020 storm season play out?